So whenever we deal with geometric sequence and series, your sequence is going to deal with if you are constantly multiplying by a constant term. So whenever we talked about arithmetic sequence, it was adding or subtracting by a common term, and we called it the common difference. Okay? Whereas with a geometric sequence, we are multiplying. Sometimes whenever it goes down, it looks like we're dividing. That's the same thing as multiplying by its reciprocal. So remember, dividing by 2 is the same thing as multiplying by 1/2. So on the first part, whenever we identify if a sequence is geometric or if it is not, then what should happen is our values, whenever we divide, if you pick any number in our sequence, okay, or any two consecutive numbers, they should always be the same. So like if we picked 12 divided by 2 or 12 divided by 6 and we got 2, it should be the same thing if we go down the line and have 42 and 30. It should be the same value. Okay, where here they are not. Okay, 42 divided by 30 is not the same thing as 12 divided by 6. Okay, if you look at it, we're multiplying by 2 here, but we're not here. Or if you think about it, we're adding 6, we're adding 8, we're adding 10, and we're adding 12. This one would actually be a quadratic and not arithmetic or geometric. Whereas the bottom one does have a common ratio of 1/4 the entire time. Okay? Remember, we do not write it as division, we write it as a fraction. If it's going down, it'll be a fraction. Okay? Or it'll be a number less than 1. Okay? You always pick a number that's further into the list and divide it by the number that came right before it. So 64 divided by 256. 1 divided by the 4. So if we tell whether a sequence is geometric, what do you think on the first one? Yes, no, maybe. Yes? What are we multiplying by each time? Yes? So my common ratio is 3. What about the second one? It's going down, so what do you know about your number? What is it going to have? What's your ratio going to have to be? Less than 1, right? What else is happening from one number to the next? Switching back and forth. Okay. So, Ricky, you're saying yes? Yeah. Yes. Ratio of 1/2. Now, if you're not sure about it, all you have to do is just pick two numbers that happen consecutively. So, if we go with negative 44 divided by a positive 88, it reduces to, that should be a negative 1/2, negative 1/2. If we do the same thing further and go negative 11 divided by 22, we are still going to get negative 1/2. Okay, don't forget the negative here. Same way on the third one. What do you think? Yes, no, or maybe? What are two numbers, what are going to be the two easiest ones to check? 9 and 12. I'm going to go later first. So if I go 9 and 12, what does that reduce to? 3/4. All right, I can divide both of them by 3. So if I do it again, even if I pick the next two values, if I go 9 divided by 4, divided by 9/1. Nine times 1 is 9. 4 times 9 is 36. Does that reduce to 3 over 4? No, what does it reduce to? 1/4. So, are these two the same? Are they, so is it a geometric sequence? No. So now, just like whenever we talked about arithmetic sequence and arithmetic series, you now have an easier way to write a rule. And geometric sequence is probably the easiest rule that you will ever write, because all you have to do is know what the first term is and know what the common ratio is, and then you're just going to stick the n minus 1 up on as your exponent. Okay, is all you have to do. So you have to know what the first term is, and you have to know what the last term, or what the ratio is. That is it. So in this case, where it says identify the aforementioned variables for the example, what's your first term? -1. Can we find our ratio?
Yes.
Yeah? How?
Look at the sequence.
Picking any two numbers. It doesn't matter if you pick these two. It doesn't matter if you pick these two. Just make sure you work back to front. So like -16 divided by 8 is a -2, right? So there's your ratio. So like if we would physically write this out, or how many term numbers do I have? So what's n?
5.
So n is 5. What is a sub 5? What's our fifth term? -16. So if we write the rule for the nth term in the sequence, again, our rule is a sub n equals a sub 1 times r to the n minus 1 power. What's our first term? Our first term is 27. Do we know what our ratio is, or can we find it? 1/3. How did you get 1/3? Okay, you went for the easy one, right? You went 1 divided by 3. So now can we write our rule? I hope so. A sub n equals 27 times 1/3 to the n minus 1 power. Now, so if I want to find the seventh term, where's the 7 going to go? N for n. So a sub 7 is equal to 27 times 1/3 to the 7 minus 1 power. So 27 times 1/3 to the 6th power. So 1/3 to the 6th power is 1 over 729. So I'm going to have 27 times 1 over 729 and end up with an answer of 1/27. Put it as a fraction. Don't put it as a decimal, because that's going to be a really jacked up decimal, and then we don't have to worry about getting into where do we round to, how many places do we need to round to, and things of that nature. Now, here it says write the rule for the geometric sequence where the common ratio is 2 and a sub 4 is 12. So what are we missing to make this so much easier? What don't we have? Remember, we don't have the first term. Remember, if we have a sub n equals a sub 1 times r to the n minus 1 power. So we're trying to figure out what the first term is so we can write our rule. So what are we going to plug in for a sub n? What value that we are given? 12.
Oh,
Okay? 12's it's gonna be equal to 12. Do we know what a sub n or a sub 1 is? Nope, that's just gonna be a sub 1. Do we know what r is?
2.
So 2. What are we gonna write for n minus 1? What is n?
4.
4. So 4 minus 1. So a little bit of math here. 12 equals a sub 1 times 2 to the third. 2 to the third is 8. So a sub 1 times 8. So how am I going to get rid of that 8? Divide by 8. So my first term is 3 over 2. Now can I write my rule? You bet I can. So a sub n is equal to 3/2 times 2 to the n minus 1.